Hello class, how are you? I hope you're doing good, and I hope every one of you is playing a good part regarding the assignments, and everybody is being responsible as usual. So let us start with this the introduction to mineral processing techniques. As our first lecture, we don't meet face to face, but from here, I believe you are going to learn something. I believe you're going to learn something. You have to have some knowledge of the mineral processing techniques. Of course, the general flow, what starts, what follows, and the beneficiation, especially the beneficiation process, where thereafter comes smelting. After the beneficiation process, of course, when we get what we call a concentrate, we actually might obtain what we are looking for, which is metal, but which, after beneficiation, we don't get a metal, we get a concentrate, enriched portion of the material. That means enriched portion, that means the grade is higher and higher. During beneficiation process, we are upgrading the grade of the portion, which is known as concentrate, as opposed to tailings. After that, it is what we call smelting. Smelting is like, for you who have learned the chemistry, actually all of you have learned the chemistry. Remember a blast furnace? A blast furnace where we add an reducing agent to the iron ore, and a given temperature we heat. A reducing agent is usually carbon, so we use coal normally. Coal is a lot of carbon, where we end up getting iron for steel manufacturing. So it's called smelting, but the purity after smelting is lower. It is usually low, even though it can be sold in the market, but it can be low. Actually, after refining, in case of the metals, you need to increase the purity. We go to refining after smelting. Okay, let's talk about this process in general. As we all know, now this is what we call introduction to this process of mineral processing. That technology of converting the run-of-mine ore. When we say the run-of-mine ore, by now you know. Now that technology of converting that run-of-mine ore into enriched products. We get a portion from that ore which is enriched, and we get a portion which is not economical at that moment, which is tailings. So that technology of converting that run-of-mine ore into enriched products. Now that enriched products, it could be what we call a metal, or product, direct product. It could be a metal. You could go to obtaining gold, it could be copper, it could be iron, it could be coal, or just end up having an intermediate product which we call a concentrate. So it could be iron concentrate, nickel concentrate, copper concentrate. That's what we call mineral processing. So run-of-mine ore up to obtaining that end product or an intermediate product, which we call a concentrate. A concentrate can be sold in the markets. We usually sell iron concentrate in markets. Now the value will depend on the grade of the metal, the grade of that concentrate. Okay. So the process as usual starts with run-of-mine ore, but you know the size. And the mineral we're interested in is not exposed. So we usually take the run-of-mine ore, we go to a process called milling, kusaga in general, milling. That means after milling, which is done by crushing, by using crushers, and grinding by using mills, right? Crushers and mills. But I left it to you, so you can go through the notes or the references on primary crushers or primary crushing, secondary crushing, tertiary crushing. That technically, that process of size reduction of the run-of-mine ore, that process of size reduction by crushing and grinding or simply by milling is technically known, the terminology we use for that process, that size reduction process, is comminution. Comminution, of course, this is not the first time you hear it, because we talked about it a little bit when you are being introduced to small-scale mining techniques, if you remember, comminution. Okay? And what the purpose? The purpose is liberation. Remember liberation? Freeing up of mineral particles in the ore. They have to be freed so that the next processes can be achieved. Okay, so we have that run-of-mine ore going through milling, reduction in size, or comminution in general, by crushing and grinding. Now that's one is called comminution, with the aim of liberating the mineral particles locked in those rocks or ore. Okay, so that's what we call now it's like the first process in the beneficiation process. We have to liberate the mineral particles. How do we liberate the mineral particles? Beneficiation in general refers to that enrichment process, whereby you have to liberate the mineral particles locked in the ore, and then when they are freed, when they are liberated, that's when we have to start the next process, which is separation. Okay, you get my point? Because you cannot separate if they are not liberated. You cannot concentrate if the mineral particles are not liberated. So during crushing and grinding, you are liberating the mineral particles in the ore. Okay? On separation, that's where we achieve concentration. And we get a concentrate. That's a product of beneficiation. So you have three sub-activities under beneficiation, which is liberation, separation, and concentration. Concentration and separation, it's like a similar process. It's like the activities are the same. Okay? There is just a small technical difference, because after separation, you might again start concentrating to enrich a product more by different techniques. Separation is easy to just understand, because separating, you can do that by sorting. For those who've been to Tanzanite mines, we just sort. This is Tanzanite, man. You see how it behaves. I mean, in the color, how you see it, just visual. So this is Tanzanite, this is gangue minerals, this is Tanzanite after liberation, just by sorting. But you could sort by using some other properties. Let's see, you go on. So under beneficiation, we have liberation, separation, and concentration. Actually, the process is milling. From run-of-mine ore, you do, and then you do milling, which is by crushing and grinding. Of course, there is a size required in comminution to be reached for some mineral particles to be fully liberated. And it depends on the character, let me say, it just depends on the size, the grain size of the mineral particles. Because there you cannot say, okay, to what size we crush and grind. Let's say the iron ore should be the same size when we crush and grind the gold ore. Okay, so they are predetermined sizes at which we say, okay, at this size, that's where these minerals are freed. Okay, it is usually predetermined, so that the other processes of separation and concentration can be easily achieved. Because if you don't know the size to what you're supposed to liberate the mineral particles in the ore, you might lose. You may not be able to concentrate if they're not fully liberated. And if they're over liberated, if you reduce the size to beyond the required size, that means you might lose some of the mineral particles in various processes. For example, the gravitation method. You remember gravitation, gravity concentration, okay? You remember gravity concentration, that's what I mean. Concentrating by gravity. You remember how particle size behaves of gangue minerals and the valuable minerals. The particle size behave differently due to the size. When they are flowing, the particles, they might behave differently due to their size. So the size have to be predetermined. So we know, okay, we are crushing and grinding this to that particular size. It was predetermined that particular size is the best. That's why you use sieves. That's why, of course, you are studying sieve analysis. Sieve analysis, perhaps you've already done it in the laboratory, or you are going to do it, because we have to have that knowledge of sieving. We are interested in the sizes. Okay? So we have milling after run-of-mine ore, and then you have to separate, that's after liberation, and then concentration, to get a concentrate, which is a enriched portion. And after that, of course, that enriched portion, now to get a metal or a mineral we're interested in, that's where we go to smelting.